Hello and welcome to a video on the natural base or the number e. Okay, so this is a number that we're going to see the definition of right now. Okay, so first of all, a quick exploration. We're just going to plug in numbers here. So we're going to plug in to this function right here, f of n equals 1 plus 1 over n to the nth power. Notice that there's two things happening here. Each time you increase n, you add a smaller piece, but at the same time, you multiply it the inside of the parentheses more times. So there's kind of like two forces. So when that happens, sometimes we end up with approaching a certain number. And we can kind of see in the curve below, just focus on the numbers in here first, and we'll see what this number actually is. All right, so we're going to first plug in 1. So we're just going to plug into our calculator 1 plus 1 over 1 to the first power. And that's just 2 to the first power. That's just 2. All right, then we're going to jump up to 5. So we're going to plug in here 1 plus 1 over 5, but this time we're going to raise that to the 5th power. And that's approximately 2.4883. And I'm going to let you take a minute and see if you can get the other numbers. Just round them to the nearest, say 10,000th, 4 places. Okay, so one thing that we notice here is that these numbers, even though n is increasing by greater and greater gaps, the number is not increasing or changing very much, right? And it's actually approaching a limiting value. And that number is e. So e is defined as, it's the limit as n goes towards infinity of this expression 1 plus 1 over n to the n. So as you get bigger numbers, you're going to get closer and closer to the actual value n. You'll never actually reach it because it's irrational. You can't express the entire number. But this is, for our purposes, this is approximately what we got when we put 10,000 in. It's approximately 2.718. You rarely need it for more accuracy than that. And here's a graph of what we actually just did. The blue curve is the graph of this function, and the green line is that 2.718, and the curve is approaching it. And as n gets larger and larger, it's going to get closer and closer, but never quite touch it. Okay. All right. So some interesting things about e. So why is this number so important? Well, there's a lot of reasons it's important. We're going to see some applications as we move forward, but this number is often called Euler's number, named after Leonhard Euler. As I wrote here, pronounced Euler, just in case you're reading this, this is an Euler number. So that kind of makes my students connected to this number because our mascot is Oilers. All right. Here's a cool property with the number e doesn't happen with anything else, and that's the slope at any point on the function f of x equals e to the x is e to the x. Now, what does that mean? It's kind of illustrated in this diagram here. The slope at a point means the line tangent at that point. And so if we look, for example, at 0, when x equals 0, then we would get e to the 0. Anything to the 0 power is 1. And if you look at the slope of the curve right here, that slope is equal to 1. And the same thing for any number, but the easy ones to look at is when x equals 1, then you get e to the first power, which is e. And the slope right here is e. And you could also look at the slope when x equals negative 1. E to the negative 1 is 1 over e. And the slope right here, it's not drawn in, the slope right here is 1 over e. That's about 1 over 2.7, right? A little bit more than 1/3. All right. Here's another cool thing about the number e. The area under the curve y equals e to the x. So this is the graph of the exponential function y equals e to the x. The area under the curve at any value of x is e to that value of x. So the area, the blue shaded area, is e to, it looks like right here is about maybe 1.1. So that would be the area would be e to the 1.1. Another interesting way to calculate e is using factorials. So this is 0 factorial is defined as 1, so this would be 1 over 1 plus another 1 over 1. Now 2 factorial means 2 times 1, so this is 1 over 2. And then 3 factorial means 3 times 2 times 1, that's 6. So that's 1 over 6. And 4 factorial means 4 times 3 times 2 times 1, and that's 24, right? So that's 1 over 24. And then 5 factorial would be 24 times 5. This is 5 factorial. So that would be 120. So that's 1 over 120. And if you add these all together, if you could go forever, you would have e. You can't go forever. Wherever you stop, you're going to get closer and closer to e, depending on how many terms you have. If we add the terms that I have right here, this is already approximately equal to 2.717. And it would just get closer and closer to the actual e as we keep on adding terms. Okay, this is an interesting property of e right here, is that if you take any number, I just took 10 for an example, you can divide it into parts. So if we divide 10 into 2 parts, we get 5, right? 5 into 2 parts, 5 times 5, if we're looking for an area. If we divide 10 into 3 parts, 3 1/3, and raise that to the 3rd power. Divide 10 by 4 parts, we get 2.5. Divided by 5 parts, we get 2. Well, the one that's closest to e, which is this one, the pieces of any number closest to e, multiplied by itself however many times it is that number broken up into, that will always be the largest product. So 2.5 to the 4th will be larger than 2 to the 5th. It'll be larger than 3 1/3 to the 3rd. It'll be the largest product. Just an interesting piece of information. And the last one here, Euler's formula. This is a real formula. It's often considered one of the most beautiful formulas in mathematics. It's just so simple and elegant. And here you can kind of see the connection between e, the natural base, I, which is the imaginary unit, pi, and 1. Okay, e to the I pi equals -1. And of course, number 7 would be lots of applications, which we will see. So I'm not just throwing it out there, say, yeah, if you take another math class or if you're an engineer, you'll see these. We'll see a lot of applications with with e. Okay, I hope you found this video helpful. Remember, the most important thing here is that whenever you see e and you're doing anything with it, you can usually just approximate it, and that's going to serve most purposes. Okay?